Hi everyone and welcome to the Learning Curve. In this video, I will be looking at SBAC practice questions for middle school students in grade 8. This is the first in my series of lessons that I will be conducting on SBAC type practice questions to help middle school students to prepare for this high stakes national examination. The first question that we have here is to select all categories of numbers that contain the square root of 16. So first we need to know what the square root of 16 is. And when we evaluate the square root of 16, we'll get an answer of 4. This is because the square root of a number means what number can I multiply it by itself to produce the number under the square root. In this case, the number is 4. 4 multiplied by itself will give us 16. So the square root of 16 is 4. Now let us ask ourselves the question, in which of these categories would 4 fall? Is 4 a natural number? Yes, 4 is a natural number. Natural numbers are counting numbers beginning at 1. So 1, 2, 3, 4, 5, etc. are all natural numbers. So yes, 4 is a natural number. We're selecting all categories in which 4 falls. Is 4 an integer? Yes, 4 is an integer. Integers are negative and positive whole numbers, and 0 is also classified as an integer as well. So negative 2 is an integer, negative 3 is an integer, positive 1 is an integer, positive 3 is an integer, positive 10 is an integer. So integers are basically negative and positive whole numbers in addition to 0. So 4 would definitely be an integer. Now is 4 a rational number? Now what are rational numbers? Rational numbers are numbers that can be expressed in a fractional form. In essence, rational numbers are numbers that can be expressed in the form p divided by q, as I have written here, where the denominator q is not equal to 0. And indeed, the number 4 can be written as 4 divided by 1, just like any other natural number and any other integer. They are rational numbers because they can be written as a number divided by 1. Any number divided by 1 leaves that number unchanged. So 4 divided by 1 would be the same as 4. So yes, 4 would be a rational number as well because it can be expressed in the form of a fraction p over q, in particular 4 over 1. 4 is, however, not an irrational number. Irrational numbers cannot be expressed in a fractional form p over q. And that is what separates them from rational numbers, which can be expressed in that form. So irrational numbers cannot be expressed in the fractional form p over q, but since we have already shown that 4 can be expressed in a fractional form, then 4 would not be an irrational number, so that's out. What about whole numbers? Whole numbers are counting numbers, but they also include 0. So 1, 2, 3, 4, 5, 6, 7, 8, etc. They are all whole numbers, and 0 is a whole number as well. So definitely 4 would also be a whole number. So the answer is A, B, C, D, E. These are all A, B, C, E rather, A, B, C, E. These are all categories in which 4 will fit. 4 is a natural number, it's an integer, it's a rational number, and it's a whole number. Now let's look at number 2. Which of the following statement is not true about a set of real numbers? Let's understand firstly what are real numbers. Real numbers are basically any number that has a defined value. So any number that you can find on the number line, whether it is a negative number or a positive number, whether it is a fraction or decimal, however large or small it is, it doesn't matter as long as it has a defined value and can be found anywhere on the number line, then it is considered to be a real number. So let's see which of these statements would not be true. Let's start with A. A says every integer is also a rational number. Every integer is also a rational number. And this is absolutely true because integers are negative and positive whole numbers and zero, and all of those numbers can be expressed as fractions, as we illustrated in number 1. A number like 4, which is a real number, can be expressed in the form 4 over 1, which is a fractional form, which makes it a rational number. That is the same for all real numbers. All real numbers can be expressed in the form of every integer can be expressed in the form of a rational number. So this is true. And let's talk about B. The number 0 is a whole number. Yes, it is a whole number as we defined a whole number earlier. Whole numbers are all counting numbers in addition to 0. 0 is also an integer because integers refers to negative and positive whole numbers in addition to 0. 0 is also a rational number because it can be expressed in a fractional form. 0 can be divided by a constant number, q, any number, whatever that number is, it doesn't matter, as long as the denominator is not 0, which is consistent with the definition of a rational number. So certainly 0 is also rational. It's a whole number, it's an integer, and it's a rational number. So that's also true. Let's now look at C. The number square root of 16, remember, the square root of 16 is equal to 4. And this is saying the square root of 16 is an irrational number. That's not true. The square root of 16, which is 4, as we illustrated in number 1, can be expressed in the form of a fraction, 4 over 1, and any number that can be expressed in the form of a fraction is a rational number. Irrational numbers cannot be expressed in the form of a fraction. So the answer as to what is not true is definitely going to be C. So the answer for number 2 is indeed C. Now let's turn our attentions to number 3. It says, which of the following number is irrational? Remember, from my earlier definition, irrational numbers are numbers that cannot be expressed in a fractional form, P over Q. P over Q is a fractional form, and this is the form that rational numbers can be expressed in, where the denominator Q is not equal to 0. And why the denominator Q is not equal to 0 is because we can't divide by 0. When we divide by 0, we get a result that is undefined, or maybe you might get a math error on your calculator. Rational numbers can be expressed in this form, P over Q, where Q is not equal to 0. But irrational numbers cannot be expressed in this form. So let's see which of these would be irrational. Negative 0.75, that is the same as negative 3 over 4. So that can definitely be expressed in a fractional form. 0.75 or 75% is the same as 3/4 or 3 over 4. So this is rational. 0.75, negative 0.75 is a rational number. The square root of 25 is 5, and 5 can be expressed as a fraction, 5 over 1. So this is also a rational number. Obviously, 2/3 is a rational number as well because it is in fractional form. Pi, which is approximately 3.14, but it's really actually a very long decimal value. It goes on and on and on. Pi is irrational. So the answer here is D, which is pi, which is approximately 3.14. But more precisely, it's actually a very long decimal. It has a very long trail of decimals. And to be precise, it is 3.142857142 and keeps going on and on. So pi is an irrational number. So the answer is D. Now let's go to number 4. Number 4 says, which two consecutive integers is between 50, square root of 50, or which two consecutive numbers is the square root of 50 between? Two consecutive numbers mean two numbers that follow right behind each other. So for example, 1, 2, 1 and 2 are consecutive numbers. 2 and 3 are also consecutive numbers. The first thing we're going to want to do here is to know what the square root of 50 is. So that's something you can pick up from your calculator in the SBAC examinations, right? So we'll evaluate the square root of 50. And when you evaluate the square root of 50, remember that the square root of any number refers to a number that can be multiplied by itself to produce the number under the square root itself. Now, the square root of 50 is 7.07, approximately 7.07. So that's the first thing we need to know. What is the square root of 50? It's approximately 7.07. And we just need to look at the options now and decide which two numbers does 7.07 fall, which two consecutive numbers does 7.07 fall between, and that's clearly between 7 and 8. So the answer is C. Now, our next question is, place the following numbers in the order from least to greatest, from the lowest to the highest. So, first of all, we need to know precisely what each of these numbers are. So, we have 3.1. I'm going to rewrite these. 3.1, we know what that is. That's a precise value. The square root of 9 is 3. 3 multiplied by itself gives us 9, so the square root of 9 is 3. We said earlier that pi is approximately 3.14, approximately. And let's see what 10 divided by 3, when we divide 10 by 3, we're going to get 3 and a third, or 3.33 recurrent decimals. So let us now put these in order from the lowest to the highest value. So the lowest value in this here is going to be the square root of 9, which is 3. So 3 is the lowest, which is the square root of 9, so that's the lowest one. Then it's going to be followed by 3.1, that's the next highest one. And then the next highest after 3.1 is 3.14. And then the very highest one is 3.33, or 10 over 3. So now we've ordered these values from the lowest one to the highest one. This is 10 over 3. So the answer is clearly going to be A. Remember, 3.14 is pi. So I could replace the 3.14 here with pi, as I did with the other numbers. So the full order is root 9, 3.1, pi, and then 10 divided by 3 from the lowest to the highest value. And so that's why A would be our result. All right. Thank you very much for tuning in to this first lesson in my series on SBAC preparation questions for middle school students in grade 8. Much more to come. Stay tuned. Remember to like, share, and subscribe.